When attempting to corral fish in a rectangular tank, a partition made of mesh and equal to the width of the tank is created, as seen in this illustration. And once in the tank, this partition is dragged from one side of the tank to the next, with the intention being to force all of the fish to one end of the tank, thereby creating a small work area. Once done, one side of this partition will contain water, while on the other side will be your fish. This temporary work area will be where you conduct your data collection, grading, or harvesting. This advantage makes all of the above processes easy enough that one person can take his or her time to execute them. In a circular tank, however, the central issue is the difficulty in corralling your fish. The method used in this example could not be employed in a circular tank with the same degree of success. To illustrate, let us pretend for a minute that you were to make a similar partition as in the case of the rectangular tank and ensure that it measured the same as the diameter of the circular tank. Such a partition would obviously have to be placed in the dead center of the tank, as in this illustration. This heavily contrasts with the inherent ability to create small workspaces when using rectangular tanks. The bottom line is that a circular tank does not allow for the efficient corralling of all your fish, using the method applied in rectangular tanks. This means that there are only two options available for catching fish in a circular tank, and they involve a net which is certainly more flexible. The two options available for corralling your fish in a circular tank. The first is to use a net to corral fish in one area of the circular tank, while the second is to drain the tank. Using a net to corral fish in one area of the circular tank. In this illustration, we see a net with floats at the top and weights on the bottom, which help to keep it open. You should immediately notice that it is very different from the wire mesh used in the corralling example talked about in a rectangular tank, in that it is much more flexible. The purpose behind this flexibility will be revealed later on as I describe how it facilitates the corralling of the fish. In the illustration on the screen, you are shown the first part of the corralling process used in circular tanks. Either side of the net is held by two persons, as seen here, and their sole objective is to walk in opposite directions around the edges of the tank with the net to ensure that as many of the fish are surrounded. After which, they then close in on the fish by walking closer and closer, thereby creating a small work area. This second illustration shows the net having been rolled out and around the tank, while this other illustration depicts the third part of the process where the fish have been corralled. It should be noted that you will need a holding tank within which you place the fish that have been measured so as to prevent double sampling. And this is due to the fact that despite your best efforts, the spaces at the sides where the net and tank meet, as seen in this illustration, as well as the spaces on the bottom where the net and the bottom of the tank meet, as seen in this illustration, create opportunities for fish already measured to find their way back to the side where fish are being sampled, while at the same time simultaneously creating opportunities for fish not yet sampled to make their way back to the larger section of the tank, potentially throwing off the validity of your sampling.